All right, class, let's have a little introduction to energy and talk about two associated concepts. So what do I mean? We're gonna describe the energy of an object, figure out does it have energy, what gives it more energy, and I want to know if it forms or transfers that energy. So these are the two associated concepts I want to learn about too. What is energy? Energy is the ability to move something or change its direction. So let's take Mr. Rip here. He's not a very good soccer ball. He like hits this soccer ball. He's accurate, but he doesn't give it that much velocity. He gives it some velocity moving to the right. And now this object has kinetic energy. And kinetic means motion. So this is otherwise known as motion energy. Motion energy. Right now, you might be able to hear Frankie snoring on the bed in the distance. He has no motion energy. But this soccer ball certainly does. It's going to move to the right, and it's going to pink. It's going to knock this domino down because an object that has energy has the ability to move stuff or to move something. Now, here we have World Cup champion Lionel Messi. He takes a punt at the ball, and it's going fast. So I'm going to draw its velocity vector a lot larger because he's given it more velocity. And if he's given it more velocity, he will give it more kinetic energy. Because kinetic energy is the energy of motion. If you got more motion, you got more kinetic energy. And that means, whoa, boom, he like knocks the entire, he like breaks the stool and the domino like flies. So it moves a lot. A physics teacher that I learned with told me once that energy is also, I like to think about it as the ability to smash stuff. And I just love it. It's a perfect definition for just thinking about what energy is. If you can smash something, you got energy. Let's take this paperclip here. Right now, this paperclip, it's right here next to a house of cards. It doesn't really have any energy. It doesn't have any at all right now. It's at rest. But if I pick it up and I bring it up to a height, I have given it energy. What? Now that it's at a height, it's got energy? It totally does. If I bring this paperclip up to a height, it now has the ability to smash stuff. It's going to fall, and it's going to hit this house of cards, and it's going to smash that house of cards. So what type of energy does this paperclip have? It has gravitational potential energy. Gravitational potential energy. And I took an object that has mass, I rose it up to a height, and it happens to be on planet Earth, which has a gravitational field. So if you got mass, height, and gravity, you're going to have gravitational potential energy, otherwise known as GPE. Now, what gives you more GPE or more of this type of energy? Well, if I took this piano and I rose that up in the sky about a meter, I don't know, and I put that piano at a height, it has more mass, and so it's going to have more gravitational potential energy. So I just want you to be thinking about what gives an object more energy. The unit for energy is the joule. We just use that as the way to say how many units of energy an object has. And this paperclip doesn't have that many joules. It might have, I don't know, like 0.05 joules. Not that much. It doesn't have the ability to smash that many things. This piano here is probably going to have like 5,000 joules. It's going to have a lot more. In fact, this house of cards never stood a chance. Boom, boom, boom. It's probably going to like break this little flimsy floor here. I don't know, I'm going to make this floor a little bit more robust. There we go. Protect the floor from dropping pianos by physics teachers. Okay, so let's learn about these two other ideas here. Energy is something that can be transferred or transformed. Let me use a different color for each. Let's do this beautiful pink. Whoa, I forgot to change the size of my pencil. Boom. Transfer. So let's think about energy transfer. Energy transfer. Energy transfer is when energy goes from one object to another. One object to another. For example, if I had a domino next to another domino, next to another domino, these are perfectly drawn dominoes. I love my art. And this domino falls over, it's going to transfer energy from domino 1 to domino 2. And then that one falls over and it transfers energy, and then it hits that one and energy is transferred, and then these dominoes start knocking each other over. They're causing the other one to move and give them kinetic energy. So energy transfer is when energy goes from one object to another. And I like to think about, these little things called this little video here. This is a Rube Goldberg machine. And, it usually has like a marble or something, and it hits the cup, and then it rolls down a ramp, and it hits the box. And any time these objects touch each other, they exert a force, and energy is transferred. Now, what is energy transformation? We'll use another color here. Let's use orange. I don't know why my voice goes up when I think of a color. So energy transformation. And transform. More than meets the eye. Okay, so transform. So anytime energy changes form, it's changing types. So for example, we already learned about GPE and kinetic energy. And let's just think of like a simple marble on a ramp. So here's your marble, and it rolls down the ramp. It starts at a height, it ends with no height. This object transformed its energy from gravitational potential to kinetic, because right now it's moving really fast after it rolled down the ramp. So it started with GPE, and then the marble ended with kinetic energy. So the best way to say that in like a complete sentence would be, the marble transformed its energy from gravitational potential energy into kinetic energy. So that's what we mean when we say transformed. It's in the same object, but different type. Capiche? Caposh. All right, forms of energy. Let's just sort of rocket through this really fast, because these are really just identifying or matching definitions and just categorizing, and I think you guys can do this real simply. So let's think about forms of energy. There are many forms or types of energy. We've learned about gravitational and we learned about kinetic. These forms can be categorized as mechanical or non-mechanical. Let's look at the mechanical ones first. When you think mechanical, think machine. Let's think about this roller coaster here. Oh, I'm going to try to get a better grab of it. There we go. So if it starts moving up this ramp, it is now at a height. It's sort of kind of flying above that. Oh, well, such great animation, Mr. Riparetti. Thank you very much. So this roller coaster is up here at a height, and it's on planet Earth, which exerts a force of gravity all around it. It means it's got a gravitational field. So it's got GPE. And GPE is a type of mechanical energy. I hope you guys didn't notice that all these riders flipped around. If this was my roller coaster, I'd be sued. Now, as the roller coaster rolls down, again, that energy is transformed into kinetic energy. And that is another type of mechanical energy. So gravitational potential energy and kinetic energy are two types of mechanical energy. Another type of mechanical energy is elastic potential energy. Have you ever pulled back a bow and arrow before? It's got like this elastic band on it, this string, and as you pull it back, you are storing energy in that elastic band. And so we'd call that elastic potential energy. You have now the potential to smash stuff. And you can move something with a spring as well. So this is a jack in the box. And if you squish the jack in the box, if I did some work and I pushed with a force and I pushed over this distance and I got that jack in the box inside of this box here, I have now given this little system, this object here, I've given it spring potential energy. Spring potential energy. And yeah, it's all it is just energy stored in a spring. And you're just thinking about mechanical energy, like think machines, right? A spring is sort of like a little mini machine. So those are the different types of mechanical energy we'll be looking at: gravitational, kinetic, elastic, and spring. And let's look at the non-mechanical forms of energy. If you move your hands back and forth and rub each other, you could be washing your hands, which would be great. And you are this because we have some velocity here. You could say, there is kinetic energy, and Mr. Rip, you put that in the wrong box because kinetic energy is mechanical, and you would be right. But what I want you to look at are these little wavy lines, because that is the heat that emanates from that frictional force. Can you guys hear my hands rubbing against each other? That the heat, the warmth that I feel, that's heat energy, but we like to call it thermal energy. Thermal energy. Let's just go through these really fast because I think you guys might be able to identify them easier without me sort of yammering on. Light bulb. What kind of energy? Light energy. No doy. A copper wire that carries electricity, or it carries electrons in a current that flows through. That's electric energy. Gonna take you down to Electric Avenue. So right in there, electric energy. In a battery. What the heck is a battery? Has anyone ever accidentally dropped a battery or broken a battery, or maybe you're a curious physicist and you cut one open and it's a bunch of goo in there. There's chemicals in there, and a battery stores chemical energy. There's chemical energy inside batteries. These are just other types of energy in the non-mechanical category. This is a magnet. We got magnetic energy. Magnets have the ability to move stuff, and they have this magnetic energy. This is supposed to be a drawing of a speaker that I drew, and it's producing sound. Sound waves travel through the air, and this is sound energy propagating through a room. Now, this is a drawing of an atom, and if you could, separate the protons from each other and you can perform some nuclear fission, you would be messing around with nuclear energy. Nuclear energy. That's why I drew that little nuclear symbol there. So these are just other non-mechanical forms of energy that we think about. So I just want you to look at these two boxes and just think, okay, what are the types of energies that are associated with the mechanical energy category, and what are the types of energies that are associated with the non-mechanical ones? And I like to think of these ones as more of the weird ones. I don't know why, they're just weirder. They're like the invisible ones that are harder for us humans to see. Usually we can't really see these types of energy. Okay, so oh, whoa, what's this? This is a wind turbine. I'm getting so excited by my own drawings. This is a wind turbine, and it's harnessing wind energy. And I want you guys to think. I left it out of the box, either box. Does it go in the non-mechanical category, or does it go in the mechanical category? And I want you to think about it for a second. What would wind energy be? Non-mechanical, or would it be mechanical? And I'll let you guys just chew on that idea. There's actually sort of several forms of energy besides wind energy in this drawing. And if you come up with any ideas for what category it should go in, send me a Neo message. I'd like to know. All right. Right on, team.